Hello, everyone, and welcome to today's webinar session. Thank you all for joining us today and spending your lunch break with us. Just a reminder that this session is presented by the Master of Science in Engineering and Master of Science in Operations Management programs here at the University of Arkansas. My name is Mindy Hunthrop, and I work primarily with the Master of Science in Operations Management. So today, I'm happy to present to you Dr. Richard Ham. He is the Associate Director of our MS in Operations Management and the MS in Engineering Management programs in the Industrial Engineering Department at the University of Arkansas. So Dr. Ham is a transportation executive with over 37 years of experience. He actually is retired from the U.S. Air Force and Homeland Security, where he held several different regional and national leadership roles. So for our program, he teaches a leadership course, a global competition class, Homeland Security, and a few of our unmanned aircraft systems courses. So with that, I am proud to present to you today Dr. Rich Ham. So I'll turn it over to you, Dr. Ham.
Thank you, Mindy. Thank you for joining us today on this topic, which is becoming more and more not just a new topic or a startup topic, but actually is beginning to become what I predict will be a staple, especially in supply chain and other parts of operations management over the next few years. Thus the title, Stop Droning About Unmanned Aircraft Systems and Actually Do Something About It. And what I'm going to show you today, I hope, if you aren't already aware, is that your competitors, many of them are already in this space. We're going to talk about a couple of things. First, the background, and the focus on systems today will be on aerial systems or aircraft, but land and maritime unmanned systems are also emerging, and we're now beginning to see not just a merger of the technology, but also a merger of those that are used in different types of supply chain and inventory management. I'm going to talk to you some about the current uses, those things that absolutely are ingrained and using them. We're using them at the university, both for research and things as what appear to be somewhat simple as the Razorback football game, but also more as far as we see current uses in public safety, and now more and more in supply chain, inventory management, and soon to be actually deliveries. We're going to talk about emerging use, but I will tell you now the emerging use that I'm speaking to. A year ago, I would have given this discussion, this presentation, and the emerging use, I would have told you people are working on this, we should see it soon. Now the emerging use, what I would tell you is it is being used. There are actually companies in this space. They're actually using it for different in inventory management and supply management and yard management, and also optimization of movement. And then I'm going to spend a little bit of time talking about the compliance issues and skills required, but more importantly, some recent, within the last 2 weeks, some very recent developments in what has changed in the use of unmanned systems and the basically revamping of, in the United States, the Federal Aviation Administration rules based on mandates that they've been given in the law. First off, I always like to give some background. I hear people talk constantly about, hey, this is really new and we're just into this space. First, I would tell you is the first unmanned aircraft flew in 1918, the Kettering Bug. It was flown as soon as really a rudimentary type of gyroscope, not exactly a gyroscope, but nonetheless something that would allow an aircraft to be put in a direction without control inputs and for it to continue that direction. So since 1918. But in the space of really looking at unmanned aircraft as we have to manage what's happening in that space. It could be an actual threat. That goes all the way back to 1944 in the Chicago Convention. And I put this quote here to give you an idea of what was happening, but really in World War II, the V-1 and the V-2 rockets were actually perceived to be such a threat that when they stood up the International Civil Aviation Organization in 1944, that became part of the United Nations when the United Nations stood up in 1947, there was a mandate that you had to get authorization from a nation state. You couldn't fly unmanned aircraft in another state. It was actually a requirement for you to coordinate and deal with those type of aircraft the same way as you did with manned aircraft. So I bring that background up to say it's not brand new. It's something that we have struggled with somewhat, but we haven't had the kind of issues that we have experienced in the last few years, primarily because in that space, it was very expensive. It wasn't just a hobby. It was something that was expensive if you had unmanned aircraft that were of any size. I don't expect anybody to be an attorney or a regulator, but I will tell you that in the United States, for some time, we've had regulations, specifically in Section 336 of the Federal Aviation Authorization. We had a amendment basically that gave hobbyists, and remote hobbyists have been flying for some time. And in one of the regulations, 14 of CFR, Code of Federal Regulations 101, those hobbyists were given an exemption to fly. What's happened in the last 2 years is some very significant changes, and that is the advent of 14 CFR Part 107, which actually many of you have probably seen the requirement to get a certificate, a remote pilot certificate. It looks like a pilot certificate. You have to take a test or a checkout if you're already a manned pilot, and then you have to be able to demonstrate proficiency every 2 years. That has totally changed the way that we looked at remote vehicles and using them in the airspace of the United States. Public exemptions, while they always existed, were pretty low, primarily contractors that were working on defense or law enforcement exemptions, and they were operating to demonstrate that capability in really some public safety or defense roles. There was one section that really has only been used effectively for about the last 4 to 5 years that allowed the administrator of the FAA to provide civilians a exemption under Section 333. And that part of the law, though, almost all of it, nearly 90%, is included in Part 107. So the point of me giving this background to you is to understand this. In the last 2 to 3 years, we've made more progress in this space, the ability to operate in this space, than we did for the previous 30, 40, 50 years because of the technology. So trying to deal with that became pretty important, and that provided some obstacles for us to try to get around, especially if you wanted to use them for supply chain. Basically, I've listed here the simple rules. Obviously, it's a very big manual. But in this space now, you can use aircraft less than 55 pounds. If you're not in aviation, you don't know what Class G airspace means, but it basically means rural airspace, not within 5 to 10 miles of an airport. You have to keep that aircraft within visual line of sight, and that is a big problem when we talk about the supply chain piece. Obviously, if we wanted to deliver something, and we have to keep the UAS in our sight, that kind of defeats the purpose. We want to deliver it beyond our sight. You also have to fly below 400 feet. This is to separate from airspace where manned aircraft would fly primarily, and you cannot fly at night. So as I look at these requirements that have developed over time, you can see several of these immediately became a problem to overcome. Now, there were things you could get a waiver, and it was a very painful process. I've gone through the waiver to fly at night and the waiver to fly in certain airspace. But nonetheless, it was very cumbersome. These restrictions, these obstacles are part of what had stopped for some time the ability to enter supply chain and inventory. You also had to fly below 100 miles an hour, and you had to have a method to recognize, see, and avoid all manned aircraft. You can never fly directly over people. Now, obviously, in some delivery modes, you need to be able to fly over people. It would be impossible to deliver something in a residential area, never flying over a person. So the ability to do that safely and some of the technology that's emerging for that is why this is becoming a more timely topic. When we look at supply chain and why this has become has become an emerging, basically an emerging tool that really you can hardly discount, is that we've been changing the definition of multimodal supply chains and also customer demand for some years. I'll date myself, but when I was younger, it wasn't unusual at all to purchase something and it's allow 6 to 8 weeks for delivery. Customers in the supply chain, especially in retail today, would not tolerate 6 to 8 weeks delivery. And in fact, what we've changed over the last few years is that anything less than 2-day delivery is looked at as being behind the times. Things that take anything more than 2 days or so are looked at as just not acceptable. So the market demand has been driving this change for some time. Same-day delivery is an emerging in many markets, especially larger markets, and is available now. The key of what's changing and what we're finding is the new same-hour delivery requirement that is becoming more and more prevalent. This idea in a metropolitan area that I need something within an hour. If I want something delivered, as for example, food delivery, 2-day doesn't really work. I want it within an hour. And that dimension includes how the supply chain would come together in air, land, and sea, in all those dimensions, and then how we would predict the models that we would use to predict that need and inventory management, which is much different than anything that we've done in the past. So obviously current, we know, and many of us have seen, that the law enforcement's using UAS for investigation and tactical processes. And while it's not key, these things in current uses aren't necessarily key in how we would transfer that specific use case in supply chain. What is important is what developed during that time. So as an example, some of the algorithms and some of the software to do facial recognition or to be able to read barcodes or other types of codes, the use of RFID to identify where different UASs are to provide some separation and also command and control ideas. The use of UAS for communications relay. Still, right now, drones are providing much of the replacement for cell phone towers that were taken out in Puerto Rico. The use to measure atmosphere, meteorology, move hazmat, all of those things are being used now effectively, and they also are being used in some of the new space we're talking about. They're being used where we traditionally had obstacles. Flying over people, that's being done with technology and waivers. Flying at night is being performed with technology and waivers. The use of different types of sensors that can detect either heat or different spectrums. That's all being used right now operationally. And now today, and the focus that we're speaking of is entry-level supply chain. The things that we're seeing now that already are providing great benefit and look like they will provide even more benefit really in the next few weeks, months, and years is what we're going to speak about and spend some time here. One of the current uses, and we certainly do this at the university now, that is used to transfer is 3D modeling. The use of 3D modeling, obviously an architect would see that as being useful. Obviously, some law enforcement would see it as useful. But those same skills for modeling, inside large warehouses, outside, that becomes key in how we now can transfer that into, as for example, delivery. If you wanted to be able to do supply chain deliveries in a metropolitan area with skyscrapers, you're going to have to start with a 3D model so that you can come up with that along with technology to provide obstacle clearance so that your UAS isn't flying into any of the buildings. It has a model to follow, and it now is able to recognize and plan the shortest route based on that model. These tools are being used today, and they can be integrated into the supply chain modeling. The same thing when we look at current uses. I have a former student now who does basic forensics of traffic accidents for court. Takes the UAS films and then puts into a simulation and shows visually based on the evidence that can be determined using a 3D model and movement to show exactly how did the vehicle in the accident or the aircraft move. Well, this type of ground-based modeling, looking at the terrain, can be used to provide enhanced, better definition of the terrain for you to move your aircraft around. It can give you more current, more than just a Google Maps satellite image, but an actual current image within a few days of areas where you might want to do a delivery. It can provide very good and detailed models of yard for yard management, and it is used right now today by several companies to provide information on their facilities that gives them the most current information possible so that they can optimize, not with a picture that was taken a year ago or 6 months ago or 3 months ago, but one that was just taken a day ago. One of the emerging uses, and when I say emerging, it's actually being used. So some of you, if you have interest in supply chain, are probably very well aware of the types of fuel savings and time savings, for instance, UPS uses. One of the things UPS uses is to model as much as possible to provide routes for only right turns. Left turns cost you a lot of time. And so you can build a model where you would have the driver have a route to avoid left-hand turns. The same kind of thing can be done in the use of drones. And we'll see some more on this, but the point is that when you make the model, when you look at the way that you can be the most efficient, it doesn't take very long to figure that you can use a UAS, you can use a drone in tandem with ground-based systems now in order to make the most efficient system. Drones inside are already being used. Several companies now are using them to solve an inventory management system. This study that was done by MIT, and although it was published in 2016, it's still valid, and in fact even more, but the point was that the discovery of this was just within the Army, and their losses that they had in inventory were managed. And if any of you are in retail, that you know shrinkage, which may or may not be from something that's being taken, or it could be something that's just lost. It's lost because your inventory system put it in the wrong area. By the time it's discovered, it may have been a timely delivery that didn't occur, and so you actually had to already fulfill that with another inventory item. Now we see that this part, the use of UAS to actually inventory and keep up to date and manage inventory more efficiently, is saving those losses. It's reducing shrinkage. It's also making sure that you can save holding costs. Obviously, there's an element, even if it's slow, of holding cost and supply chain that's generated by the fact that you know already you're going to have some lost inventory, and therefore you have to be able to ensure that you have enough safety inventory to fill it, even if you lose some. If you can reduce that, even if it's small, those savings add up over time. I'll show some videos on some, and I wouldn't even say necessarily emerging, but actual use cases that are being done now and sold. This one on yard management, and I think most of us can see how effective it would be. So we'll look at this, and then we will discuss it right after. So that company, and I've spoken to several of them, they're already using that particular technology to look at, control, maintain their inventory, to make sure if they were told that a trailer left, that they can validate that trailer did in fact leave. They can see the position of the trailer each time, not just that it was logged as leaving, but that it actually did leave. Some of the larger logs or yards, if you've ever been into a large one, like say the Port of Los Angeles would be a good example, a multimodal yard, they're changing a lot of materials back and forth. It is not unusual at all for a trailer or an entire shipment to be lost in that yard. The use of the UAS to look for and identify them based on either a code or a Q read or another type of RFID read to find it and then quickly get it back into the system is saving a great amount of time. I'll tell you, in yard management, one of our OM students actually wrote a very good paper about the use case on the use of UAS to look in a refrigerated warehouse, to look at that warehouse to see where there's thermal loss, to look and see whether or not any of the trailers that were refrigerated were losing thermal, and then to track them. That's a great use case. It allows you to not have the spoilage issue or predict ahead of time whether or not that you're going to lose one of the trailers because you're seeing a refrigerator or a refrigerator unit starting to fail, and you can see that based on the heat that's emanated with a thermal sensor. Another great use case has to do with primary, and I'm going to let this one speak for itself. I'm going to talk about at the end about why this is going to happen, already happening. These deliveries are already occurring in test cases. This was from 2 years ago, but they're already happening, and we're on the cusp of seeing an actual first market develop. So please go ahead and play that video.
Amazon is developing a service to use drones to safely deliver packages to customers in 30 minutes or less. It's called Prime On. Started a new private trial for customers in the Cambridge area of England, and on December 7th, we completed our first delivery. Customers will choose from a selection of thousands of items tucked away in a prime air fulfillment center located just over the horizon from their homes. We have been operating fulfillment centers for quite a while now, but this one is unlike all the rest. These modest-looking buildings contain innovative prime air technology. Here's how it works. Moments after receiving the order, an electrically powered Amazon drone throws its way down an automated track and then rises with the customer's package on board. These drones are autonomous. From takeoff to landing and return, they operate completely on their own. Cruising quietly below 400 feet, carrying packages up to 5 pounds, and guided by GPS. Our systems are designed to find their destinations safely. Within 30 minutes of placing the order, the customer receives their package. For this initial trial, customers can choose from the latest tech gadgets to their dog's favorite biscuits. We will use the data gathered during this beta test and the feedback provided by customers to expand the private trial to more customers over time. We're starting with 2 customers now, and in the coming months, we'll offer participation to dozens of customers living within several miles of our UK facility, and then growing to hundreds more. After that, well, it'd be easy to say, the sky's the limit. But that's not exactly true anymore, is it?
Okay, we had a little bit of washout on the sound there, but I think that you could see clearly what was happening. We had basically overseas, many places, Australia, the UK, several parts of the world, New Zealand, already have programs that are approved and actually a part of their current process supply chain. In remote areas, in Australia and other parts of the world, parts of Africa, they're being delivered now. Medical supplies, if somebody needs something urgently, it can be delivered to them. And that is an important part of, if you will, a key test to see how is it going to be when we start looking at less urgent needs, and now we see things that are everyday needs. It's easier to justify the first starts, but they're already seeing, we've seen pizza deliveries done using UAS. We have seen Amazon test. We've seen some other companies that are testing, have actual sites in some of the test ranges where they're doing delivery back and forth, flying over people. This is here now, and later on we're going to talk about why it's ready to burst open right now. So the next use case, I had talked to the residential drone delivery, but the reason that this is important, and I want you to see, and we'll talk a little bit after this video, is that it's not just a system of UAS, and that is why many people will look at it and go, well, we don't have the technology, we've got battery issues, or we have others. But when you think about using it as part of a system and optimizing as a system with both ground-based and air-based UAS, now you see some uses that emerge and are much more viable. We're beginning to already see many of those used in several areas. So if we'll go ahead and watch this video as well, and then we'll talk about it.
And all we're doing here is eliminating miles that the driver could potentially drive and helping make the driver more efficient when they do the job.
It's an octocopter. It's designed with enough redundancies to stay in the air. So if one prop should go out, it can still fly. If 2 goes out, it can still at least land. It's talking to the truck via RF, and we have 4G. Dual communications, 8 props, 8 motors, multiple systems inside there, all designed to keep it in the air. The truck is its own beacon. It's broadcasting its position. The bird is broadcasting its position. So the two. So we put a battery in there that can do the line of sight, and then when it redocks with the truck, can charge very quickly off the giant battery in the electric truck. So it's just designed to hop all day, short hops.
The FAA last year released Part 107, which basically allows for visual line of sight operation below 400 feet with the drone up to 55 pounds that can fly up to 100 miles per hour. What will happen next as the technology emerges is a beyond visual line opportunity, as well as the opportunity to fly over people.
Ultimately, if we wanted to work on any vehicle, when the regulations and the technology gets to a place that we need it to be able to do it and be safe for everyone, then we would really want to possibly anything.
That drone is the same color as the truck, is the same color as the uniform, and so it's trusted. If somebody tried to hack it, the driver at least would know about it. If we were sending it beyond line of sight 30 miles, right, and somebody hacks it, the odds of knowing what happened are very rare. But here we've got somebody basically watching it. In the end, the whole thing is softer, right? And the key to keeping it safe is to keep them talking constantly all together. Our main server is watching everything. Worst case, if we lost 4G, then the truck is broadcasting an RF signal. It can grab that and return to truck. The driver can take control at any time. It runs fully autonomously. So to have an autonomous route that all of a sudden the driver could take and say either recall it with one button push or navigate it back in case the driver saw it was having trouble somewhere. This is the first live test, right? So now that we've successfully made it through this, we just continue to develop and refine.
What happened there with the?
Yeah, I don't know. We tried to do for the photographers, so we tried to do a kind of an augmented, quick, non-traditional delivery, and something went wrong. We probably shouldn't have tried something weird like that with everybody watching. But, we're trying to accommodate you guys, and something went wrong.
Right now, we're still evaluating the technology. It's all about safety for us right now. We're obviously sticking within the regulations, but safety is the key factor. We have to make sure that our customers, the general public, and our employees are all safe. So when it's safe and it's ready to go, we'll be ready to use it.
All right, so this demonstration, the actual use, this is 2 years ago that was demonstrated, and it is now, I wouldn't say nothing is perfected, but they've already done visual line of sight or beyond visual line of sight using an updated UAS with the ability to show some pretty dramatic improvements in hardening to reduce any sort of hacking or any other kind of issues you might have by somebody trying to take them down. The good news is that while someone very sophisticated might be able to hack into one, it would have to be someone very sophisticated, and it's unlikely when we start to look at the risk that somebody would really try to do that. If they were trying to steal something, maybe, but there's some new tools, some new tracking tools, and the advent the FAA is putting in with a required RFID identifier. And the way to identify the UAS, where it is and where it's going, it is changing the game. Now that the government is coming on board and actually put it into some place for some universal traffic management, it's changing the viability of this, and that's why companies are using it. The next with warehouse inventory. This goes to what I spoke to just a moment. This is a demonstration of an actual use case actually being used for inventory control now by a company. It's pretty useful to see. You can see quickly why it would be so much better, and also you can look at other things you can improve. You can improve safety. You can reduce the amount of time that some of your employees are involved in task that they could be better utilized in something else. So let's go ahead and play this one. So not only do we get the opportunity to see how we could, I mean, clearly we can figure out what the advantage would be, but also what we get to see is the ability to do audits, to do inventory audits that we would want to do to see how fast are things moving as we expect. The other piece on the inventory management side is there are 2 companies now that have already began to use a process that have ground-based units that run autonomously that are talking to airborne units that are working autonomously. So even the forklift operator that you saw there would not have to be involved in that process. The movement would bring it out to an area for a resort to then go enter the supply chain. Okay, so we see some use cases, and we see that it's not just emerging, but already it's here. So why, what do we really have to do in order to get into space? Now, obviously, there's technology issues. I won't focus on it today, but there are some issues that we need to do in technology to understand new roles. If some of the simulations we would have used in supply chain in the past are going to have to be modified, because we're not looking at movements based on the way that a road works or the way that they have to go on the railroad. We actually have a part of our supply chain now that is going to be modeled on the shortest place between 2 delivery and acceptance points. So no longer do you have to look at traffic and the other. You're just looking at is the weather acceptable? Is the traffic in the airspace acceptable? What exactly can we do in the shortest amount of time? And then make decisions on which mode to use. There's obviously some time and really, really bad weather. We're going to have to revert to some ground-based. But in the other times, we can make up some of the lost time, if you will, when the weather allows us, when the wind, weather, et cetera, allows us to do it. So if you want to get involved in this, there's some things you do. We began over 2 years ago and realizing this was the direction to head, that you need some things. You need some tools. You need a 107 certification or a certificate of authorization if you're a public agency, or a 333 exemption. The FAA for non-public agencies, the FAA's sense now is the 333s will probably nearly all go away, because 107 allows waivers to let you do things like fly over people and other of the things beyond visual line of sight, if you can prove that you can be just as safe, and there's several operators that already have. New pieces in airspace. So I talked to you about, you're not going to be, don't expect everybody to be an expert on that type of airspace, but the airspace near busy airports. The FAA already began and is published, and the last segment will be published within a few months, of a map that will tell you that you would be able to fly in a certain area at a certain altitude with little or no coordination. You can go online. When I first started this, it would take us 90 days to get a waiver for airspace. Now you can go online. You can say, I want to fly from here to here, and as long as you're below what the facility maps show that they've been building the infrastructure for the last few years, they will approve that almost instantly, certainly within 24 hours. Operations at night and over people. Some of the new, we have a waiver here at the university to fly at night. It's based on us showing how we can do that safely with procedures and equipment, and how we're going to avoid others. There are several that are in the process or have approved flying over people, and it includes some new technology. Some parachutes as a fail-safe, doing as UPS just showed that they had some redundancies on custom-made drones where they could fly even if they lost 1 or 2 props. So as it becomes safer and safer, and you can prove your ability to have ways to mitigate any of the concerns, now we're seeing those operations happen more and more. All these things on this slide, everything here, are things that I would have listed as obstacles a year from now. Now you can look at those as actually a skill that you can develop, something that's obtainable and that you can do, so that you could begin the process of using UAS for supply chain. Here's what's exciting about this time. So the FAA Reauthorization Act was signed by the president about 2 weeks ago. Now, it did eliminate much of the 336 exemption that for hobbyists that they had enjoyed for quite some time, but it requires them to go through a testing process with their organization, similar to 107 testing, but they have to actually prove some proficiency. That change, whether one agrees with it or not, it actually is a part of a strategy to allow universal traffic management to know where all the UAS are. It emphasizes FAA infrastructure development in universal traffic management, which includes and requires, and this is probably the most important thing, it includes a mandate to the FAA that they provide a way to easily become not easily, but to become certified in beyond visual line of sight or enhanced visual line of sight, in allowing operators to know exactly what are the requirements. What do I need to do? I want to do a delivery with the UAS. What do I need to do beyond line of sight? So that you could look at it and say, all right, they say I have to have this type of technology. I'll get that, and now I can do it. The second bullet there under this section that's the most intriguing, and I would say what really this whole conversation today would focus on, is that the law now mandates, this one just signed, that the FAA come up with a way to provide exact guidance and exact certification or waiver process for a company or individual to be certified to do deliveries using UAS. And they're given 1 year, start to finish, to develop that. It doesn't mean that there won't be some bumps along the way, but the fact that there's actually been a flag planted and say in 1 year, this is it. In 1 year, operators are going to be able to use this for supply chain functions. And FAA, you have 1 year to tell them how they're going to make this happen and come up with standards they can follow. And it also requires a way to do automatic and enhanced and quick exemptions and waivers so that they turn quickly. It doesn't take a long period of time in order to get a waiver in. The FAA has already made a lot of progress in this area. Those 90, 120-day waivers are now, in weeks. If they're really complicated, if they're simple ones for our airspace, those are happening very quickly, sometimes in as little as an hour or two. And the last but not least is a mandate for test sites and educational programs that have to be funded and used by, or that are funded now by the FAA, and that are going to be used to ensure this technology is integrated. I'm not going to go through all the laws, but I will tell you this. You do have to have some skills and knowledge of, here's some key laws, but basically I talk about property rights. When someone says there's already been settled law about, hey, I own the airspace above my house, that's not exactly true, but it's kind of true. But there's already settled law that applies directly to UAS, having to do with where you could fly the UAS and not violate property rights, and the applicability of local rules that you have to follow to ensure that you do what's required for local ordinances. That's a part of the federal law. So if you get some chance to look at these, they make for some, I guess, reading to put you to sleep at night, but it's good information to know, and you definitely need to understand what the law says as well when you want to do these type of operations. There's some developing requirements in cybersecurity, and you can imagine, obviously, that what the UPS presentation, when the COO is talking about, hey, someone could hack it, that is becoming more and more a part of the process. So you're now actually seeing UAS that are developed that have anti-hacking properties, and there are ones being developed now that already have some hardening so that they cannot be affected by some typical non-military grade. The other side is the FAA authorization also granted the military and law enforcement some very specific authorities to take down an aircraft if they thought, and including an unmanned aircraft, if they believed it to be a threat. So while it may not be hacked, it certainly can be taken down if it's a threat. The opportunities, and I believe firmly right now, is individuals that have modeling and simulation skills, along with an understanding of supply chain and inventory management, are going to see this space explode quickly. I talked to you a little bit about some of the things that would be used for modeling and simulation, but right now those are having to be generally adapted. You're trying to adapt a ground model for something for the last mile delivery by UAS. You're starting to look at the way that you do distribution and maybe small warehousing or forward warehousing or hub and spoke type of development. And now you have a brand new type of delivery. That's going to require some new modeling skills, some new ways to think about how do I predict that? What do I look at the risk? How do I know how the weather is going to treat me? Some things going on in that space now, and certainly you see some software that is trying to address it being modified, but there's great growth potential that's happening. And over time, as we begin to see some of the things that it could be used for, we're going to find, I believe, that this space and students that understand all of these things together are going to be in great demand. Okay, that concludes the briefing. I'm going to turn it over to Mindy, and then I think we're going to have some time for any questions.
Yes, thank you, Dr. Ham. So just a reminder, if you're interested in either of our online programs, here's a little bit of information about those, and you can always contact me. You've got my contact information if you're interested. But as you formulate your questions, please type them in the chat box you should see that on the bottom right screen, a little option for chat. So if you've got questions for Dr. Ham while you've got kind of an expert in the room, please do type your questions there. And then I also want to remind you, here is our full webinar schedule. So you'll see that the next webinar will be Tuesday, November 27th, and that is presented by Dr. Art, and that will cover intro to data analytics and emerging real-world use cases. So kind of mark your calendar for that, and I'll be sending some information with the video for this webinar, as well as how you can register for that webinar if you're interested. So thank you again for attending today, and we will hang around here for a little bit longer for some questions. It looks like we do have a question now from Kelsey, and he wants to know, does U of A have a UAS flight or research program? Any public-private partnerships? And I will let Dr. Ham discuss that answer.
We do. So we've been preparing students for over 2 years in OM and also with CAST. We have a foundation course where the students will get certified. They'll get their FAA 107 at the end of that course and take the exam, and also learn about sensors and some of the uses. We actually teach them how to use some of the software for modeling, and they get introduced to all of that. There's a second follow-on course we co-teach that CAST has that is more involved in very specific use of sensors, modeling, things like infrared measuring. We have one that we're doing as part of a research. We're going to do a night flight here and compare what the sensor views would look like. The same thing at basically at solar noon and at solar midnight, if you will. So we do have several projects going. We have some research projects. Two, we have a pretty exciting, there's three pretty big ones, and then several that individuals are using for civil engineering and different processes. You wouldn't have to look very far or long to see some type of use and to see some of our faculty that are starting to search. We have I think a groundbreaking one starting here in about 2 to 3 weeks. And you asked another question, Kelsey, I see. Public-private partnerships, we do have some partnerships with national labs, and then we have some individuals that are trying to do work as well on some grants that are ongoing, some in the agricultural area primarily, but then there's a few. We've been approached by some startups that are wanting to do some public-private partnerships as well. So we do have those, and we pretty active. Our vice provosts that work on both economic development and in research are active, and we've got several of them going all the time. So it's pretty busy now.
All right, now it looks like we have another question. It says, there are current ground-based solutions being tested for deliveries on campus, as well as getting shelf status in Walmart stores. Are those candidates for UAS solutions also?
They absolutely are. So it's a great question. Obviously, like I said before, when you see a ground-based solution that occurs in a large solution or a large piece of the supply chain, you have to have that if the weather right now is too bad for UAS to work. But in most time, and in fact, for instance, in our area, about 90% of the time, just a little bit less, a UAS, a standard, not even a ruggedized ones that can fly in worse weather, more than 90% of the time, we can fly and do deliveries. Each of the ground-based systems that you see with appropriate controls could be used by an airborne unit. They can do it faster, and with some infrastructure, they can even become, as they become more prolific, we're going to see those occur more and more. We've got a few projects that we're looking at right now to demonstrate that, but absolutely is going to be one of the upcoming things. This year, especially with this mandate by the FAA, we're going to see more and more deliveries that way.
All right, now Dr. Ham, I'm not sure if you can see these, but there's another question that says, I'm a UAS pilot for the military flying large-sized unmanned aircraft systems. I've had to coordinate with the FAA on airspace restrictions, BLOS issues, etc. Do you think there is a future in large UAS in the private sector, cross-country or transoceanic cargo deliveries, etc.?
There absolutely is, and in fact, we've already seen some in this space. The FAA, Tyler, if you've worked with the FAA, you know that the way they work is they're very measured. They do things slowly. They will work their way through the SUAS. There's already in the test ranges large UAS. In North Dakota, they're already doing, as part of the test site there, beyond visual line of sight, using de-weaponized and civilian models of Predators that are used. They're flying well beyond line of sight, and then also returning and being used to fly. And they have a waiver for, with appropriate controls, nearly all of the state. So there's no doubt that it's heading that way. It's going to take a few years of experience to see how the SUAS deliveries are occurring, but there's no doubt that we're going to see that restriction lifted over time. My prediction would be you're going to see some deliveries. Transoceanic's easier, quite honestly, when you mentioned it because of the safety factor, but we're going to see those deliveries start on a commercial basis, not just testing, not just R&D, within 5 years.
And those are some great questions. For any of you, I know Dr. Ham mentioned this, but Dr. Ham does teach an unmanned aircraft systems class. So if you're interested in taking that class and you're not already a student or you haven't already taken it, please let us know. I'd be happy to talk with you and help you to get enrolled in that class. And is that coming up in the spring, Dr. Ham?
It is, and I would say too, we've designed that class to where it's online, and we have synchronous video section. We've had students from all over the country take that course and successfully pass their 107, then also work projects, including group projects, even remotely on producing several different modeling or using different types of sensors. So it's very well received and been used in several disciplines. So it can be done remotely as well as in person.
All right, and thank you for those questions. We'll hang around for just a couple more minutes if anyone has another question, and if you think of questions later after this, you can always email those to me and I can pass them on to Dr. Ham. So thank you all again for attending today, and we hope you enjoyed the session.